If quantum computing gets involved in AI, what are we looking at?
Well, first of all, AI is a software program. We're talking about homogenizing different kinds of essays on the web, splicing them together, and then passing it off as your latest creation. Basically, plagiarism using digital computers. It's a software question. However, quantum computers is bigger than that. Quantum computers is a hardware question.
A quantum-powered AI just cracked open the secrets of the first interstellar object we ever spotted, Oumuamua. And what it found inside has scientists completely stunned. Forget everything you thought you knew about this so-called space rock, because this discovery changes the entire game. For the first time ever, advanced quantum computing didn't just scan its surface. It looked deep inside and uncovered what appears to be a bizarre, exotic core unlike anything in our solar system. This isn't another wild guess floating around. This is a computational breakthrough that literally maps Oumuamua's hidden structure. The results suggest it's not just odd on the outside with that cigar-like shape and strange acceleration. What's inside might be even more unbelievable. A core so out of place that astronomers are being forced to question everything they thought they knew. Since 2017, this mysterious traveler has baffled experts. But now, quantum AI analysis has exposed something shocking. Signs that its heart could be made of engineered material, or something so exotic we've never seen before. The implications are jaw-dropping. And before anyone tries to brush this off as speculation, remember, the AI based its findings on hard data, its unusual path, its bizarre spin, its unexplained motion, all plugged into brutal mathematical models. What the algorithms spit out goes way beyond what regular analysis could even imagine. And here's where it gets wild. The AI didn't just find one anomaly, it revealed three. First, evidence of an insanely dense or exotic core packed at its center, wrapped by lighter layers. We're talking about a concentration of mass that no normal asteroid or comet could ever match. The quantum AI's findings get even crazier. First, it confirmed Oumuamua likely has an insanely dense central region at its core, not something you'd ever expect from a random space rock. Second, and this is where jaws drop, the AI picked up signals of what looks like artificial spin stabilization. In spacecraft design, engineers purposely spin objects to keep them steady in space. And guess what? Oumuamua's so-called tumbling motion isn't as random as scientists once thought. It actually shows patterns of a controlled spin that's just breaking down with age. And third, forget those earlier theories that this thing might be hollow, like a giant light sail drifting through space. The AI revealed the opposite. Oumuamua is not empty at all. It's packed with serious mass in its core, surrounded by multiple layers of material with different densities. If this holds true, we're not just looking at a visitor from another star system. This could be something that carries the fingerprints of engineering or contains exotic material we've never seen in our solar system. Think of it this way. Before, astronomers only had a blurry X-ray snapshot of this strange object. But now, imagine running that X-ray through the smartest computer humanity has ever built, one capable of testing millions of possible hidden structures at once. That's exactly what this quantum AI did. It dissected Oumuamua's every move, its strange flickers of brightness, its weird trajectory, its chaotic spin, and reconstructed what must be hidden inside to explain it all. So how can an AI see inside something millions of miles away, something we only ever saw as a faint dot of light? That's where things get even wilder. So how does an AI see inside an object millions of miles away? The secret lies in the raw power of quantum computing. Its ability to chew through insane amounts of data and test millions of scenarios at once. First, scientists fed it something called trajectory anomaly mapping. As Oumuamua zipped through our solar system, it didn't stick to the path gravity alone should have forced it onto. Something was nudging it, ever so slightly, and the AI tracked those tiny deviations down to the millimeter. Then it worked backward, calculating what kind of hidden mass distribution inside the object could create that motion. Imagine looking at tire tracks in mud and figuring out the exact shape of the wheels. That's what the AI did, only on a cosmic scale, mapping Oumuamua's hidden skeleton. Next came thermal backmodeling. When Oumuamua passed near the Sun, parts of it heated and cooled at different rates. NASA's Spitzer Space Telescope captured the faintest infrared signals, and when that data hit the quantum simulator, it painted a temperature map of the inside. Metals, rock, ice, they all conduct heat differently. This was like pointing a thermal camera at a wall and seeing the studs behind it. Except here, the wall was an alien space visitor, and the heat signals were almost impossible to measure. And then came the wildest trick: gravitational microlensing. Even small objects can bend the light of stars behind them. It's subtle, nearly invisible, but real. The AI dug through archived starfield data from Oumuamua's flyby, hunting for the tiniest distortions in starlight. Normally, astronomers use this to detect planets around distant stars. But this time, the AI turned that same technique on a passing interstellar object, like using a galaxy-sized magnifying glass to peek inside Oumuamua itself. By tracking how starlight bent ever so slightly around Oumuamua, the quantum AI basically built a full-blown density map, exposing what must be hiding inside to cause those distortions. And here's the wild part. Quantum computers don't think like regular machines. Instead of checking one answer at a time, they blast through millions of possibilities at once, testing endless hidden structures against the real data until the most shocking matches appear. And when the AI finished crunching those models, it didn't come back with a simple explanation. It uncovered multiple scenarios, and not one of them was ordinary. The evidence points to something buried inside Oumuamua that refuses to fit into conventional science, with implications that are flat-out revolutionary. Take the first possibility: exotic matter. If the AI is right, we could be staring at the first confirmed chunk of a dead star to ever enter our solar system. Picture a piece of neutron star crust or white dwarf material, matter so unimaginably dense that a teaspoon would weigh tons here on Earth. This isn't just exotic, it's dangerous, mysterious, and packed with heavy elements forged only in the chaos of stellar explosions. And it gets deeper. This kind of material could behave in ways that break our current understanding. It might twist magnetic fields, mess with radiation, maybe even interact with neutrinos, things that normally slip through matter like ghosts. If that's true, we're not just talking about comets or asteroids anymore. This would mark a brand new class of interstellar visitors, the actual remnants of dead stars traveling across galaxies, surviving violent explosions, and somehow landing right at our cosmic doorstep. If the AI's hint of artificial spin stabilization proves real, then the stakes skyrocket. We could be staring at humanity's first confirmed alien artifact. Not just a rock, but maybe a derelict probe, or even a long-lost vessel from a civilization far beyond our own. The structured core and that suspicious non-random spin pattern could be fingerprints of design, intelligent design, not a random quirk of nature. Think about it. Oumuamua might not just be cosmic debris. It could be technological debris, a piece of deep space archaeology from an unknown culture. Now, the quantum analysis doesn't claim this is absolute proof, but it does throw up patterns that look engineered, patterns that scientists can't just brush aside as coincidence. The possibility that this thing was built instead of simply formed naturally is very real. And even if the truth is less dramatic, say a dense metallic core from another star's planetary system, that's still groundbreaking. That would mean we're holding a fragment of an alien planet's heart dropped right into our solar system. Imagine picking up a pebble, only to find it's heavier than lead and made of something unknown to science. That's the level of shock researchers are wrestling with right now. For years, people shrugged Oumuamua off as just another comet. Some argued it was powered by hydrogen outgassing, a natural explanation. But the quantum AI has added an entirely new twist, one that makes the mystery impossible to dismiss. And don't forget, this isn't just any object. This was the first interstellar visitor we ever saw, and it might not be what we thought it was. What are the odds? That's the question everyone's asking, because this is where things get strange. Was Oumuamua really just a random rock flying by? The coincidence is almost too much. The very first interstellar object we ever detect just happens to be the one that breaks all the rules. Either we got impossibly lucky, or there's something about Oumuamua that made it stand out from the crowd and practically force us to notice it. To make sense of this, scientists have started lining it up against the other interstellar visitors we've found, and the comparisons are wild. The second interstellar object, 2I/Borisov, discovered in 2019, couldn't be more different. Borisov looked and acted exactly like a normal comet. Glowing gas tail, predictable outgassing, a clean trajectory. Its composition was so textbook comet that if we hadn't tracked its orbit, no one would have even guessed it came from another star system. Compared to that, Oumuamua looks like the oddball of the century. Then came the third visitor, 3IATLAS, spotted in 2025. Unlike Oumuamua's small cigar-shaped body, Atlas is massive, several kilometers across, making it way easier to study. Right now, the James Webb Space Telescope is locked in, gathering detailed spectroscopic data on it. And here's the kicker. Early results show Atlas falls between Borisov and Oumuamua on the weirdness scale. It doesn't bend the rules as crazily as Oumuamua, but it still carries quirks that scientists can't fully explain. This is where the new quantum AI tools come in. The same analysis that blew open Oumuamua's secrets is now being unleashed on Atlas, building a comparative data set that could finally show us what's normal and what's truly extraordinary about these interstellar wanderers. And history reminds us not to jump too fast. Back in 1967, when pulsars were first detected, their laser-like precision fooled scientists into thinking they might be alien beacons. In the end, they weren't. But the fact we even considered it shows just how easily cosmic mysteries can shake our understanding of reality. Back when pulsars were first discovered in 1967, they were so precise, so unnatural-looking, that scientists actually labeled them LGM, short for little green men. Only later did we learn they were rapidly spinning neutron stars. Could Oumuamua be headed for the same kind of twist, starting out as alien tech in our imagination, only to turn out as an exotic but natural phenomenon? Maybe. But here's the thing. The pulsar story cuts both ways. It shows us that strange signals can have natural explanations, but it also proves that revolutionary discoveries often show up first as mysteries we can't explain. And right now, a new picture is forming. Oumuamua, Borisov, Atlas, they might be the start of an interstellar family tree, a whole spectrum of objects drifting through the galaxy. Some ordinary like Borisov, some moderately strange like Atlas, and some completely bizarre, like Oumuamua. This diversity suggests our galaxy is swarming with cosmic wanderers, each one carrying clues about its origin. Some could be basic comets or asteroids tossed out of their home systems. Others might be violent wreckage, shattered planets, stellar debris, maybe even fragments from collisions involving exotic objects we've never seen before. But here's where it flips. If the quantum AI is even half right, this goes way beyond Oumuamua. This could rewrite how we hunt for life itself. For decades, SETI has focused on listening for radio beacons, assuming advanced civilizations would want to broadcast their presence. But what if they aren't sending signals at all? What if the evidence is physical? Strange objects drifting between stars, carrying the fingerprints of alien technology? That's the shift. SETI 2.0. A new era where we don't just listen, we look. What if the evidence isn't being broadcast at all, but is silently drifting through our solar system right now? If that's true, then we might be watching the birth of SETI 2.0, a whole new way of searching for intelligence out there. Instead of passively listening for radio waves, the mission would flip into hunting down physical artifacts, real objects with bizarre properties that can't be explained away. That's not just a shift, that's a revolution. And here's the kicker. The technology to make it happen is already in the works. Take Project Lyra, a bold mission concept that would send a high-speed spacecraft racing after future interstellar visitors, powered by solar or even nuclear propulsion. We're talking speeds over 70 kilometers per second, fast enough to actually catch the next Oumuamua-like visitor. Then there's the European Space Agency's Comet Interceptor, launching in 2029. This one flips the strategy. Instead of chasing, it waits. Parked at a gravitational sweet spot, the craft will hibernate until something unusual enters the system. Once the next interstellar wanderer appears, the probe will wake up and sprint in for a head-on encounter, giving us humanity's first close-up look at a true alien visitor. Meanwhile, the upcoming Vera C. Rubin Observatory is about to change the game of detection. With its monster 8.4-meter mirror and a record-shattering 3.2 gigapixel camera, it will scan the entire visible sky every few nights, spotting interstellar objects months before they cross into the solar system. That's precious time to launch intercept missions and prepare for the unexpected. And the true game changer? Pairing all this with quantum AI and cosmic forensics. Future missions could sample the isotopic fingerprints of these objects, their unique chemical codes, to reveal not just where they came from, but how they were formed. That's the kind of forensic science that could expose whether we're dealing with natural debris or something else entirely. From the start, Oumuamua's very shape broke the mold. Some analyses painted it as a stretched-out cigar, while others swore it was more like a flat pancake. But either way, nothing in our solar system comes close. The most extreme asteroids we've ever seen have maybe a 3-to-1 length-to-width ratio. Oumuamua, it's stretched out to an insane 10-to-1. And its movement, just as bizarre. Instead of spinning neatly around a single axis like most asteroids, Oumuamua was tumbling chaotically, rolling around multiple axes at once, like something that had been violently smashed in the past and never regained stability. But the real mystery was what astronomers didn't see. When comets approach the sun, their icy surfaces vaporize, leaving a visible tail, a coma of gas and dust. Oumuamua? Nothing. No tail. No outgassing. Nothing to explain why it still managed to accelerate slightly as it sped out of the solar system, as if something unseen was pushing it. Even NASA's Spitzer Space Telescope, one of the most sensitive eyes in space, detected zero signs of gas or dust. That vacuum of answers unleashed a storm of theories. Some argued it was a hydrogen ice comet, its gas nearly impossible to detect. Others suggested nitrogen ice, like frozen shards from a Pluto-like surface slowly sublimating to give it thrust. A more grounded take said it might be a broken fragment of a planet's metallic core, like our own asteroid 16 Psyche. Its reddish hue hinted at a surface weathered by millions of years of cosmic radiation. But here's the kicker. None of those theories explained everything. The extreme proportions, the mysterious acceleration with no visible exhaust, the odd reflectivity. Piece after piece didn't add up. Oumuamua remained a puzzle too big for standard science to solve, until quantum AI stepped in and rewrote the rules. These were the mysteries that finally pushed scientists to bring in AI, because the old models of physics just couldn't keep up. Quantum computing gave them a way to process all of Oumuamua's bizarre behaviors at once, testing millions of possible scenarios until the most likely answers began to surface. So, did quantum AI solve the mystery once and for all? Not exactly, but what it uncovered was anything but ordinary. The analysis revealed patterns pointing to a dense exotic core wrapped in lighter material, a structure far too complex to be dismissed as just a frozen rock or a chunk of ice drifting from another star. No single theory has been proven, but the field of possibilities has now been narrowed, while brand new ones have opened. The data points in two directions. Either Oumuamua is an extremely unusual natural object with materials rare or unknown in our solar system, or it's something that carries the fingerprints of intelligent design. Either way, this first interstellar visitor is an outlier. Nothing like Borisov, which fit perfectly into the comet playbook. Oumuamua refuses to be categorized, and that is exactly why it matters. Because in science, it's the anomalies, the things that don't fit, that spark the biggest breakthroughs. Thanks to quantum AI, astronomers now have something like a cosmic X-ray machine, a tool that can peer inside distant visitors and reveal their hidden structures. And this is just the beginning. So, what do you think? Was Oumuamua just an exotic space rock? Or could it be evidence of something engineered? Drop your thoughts in the comments below, and don't forget to like, share, and subscribe for more mind-blowing stories from the edge of science. And maybe the most exciting part? This is just the beginning. As quantum computing evolves and more interstellar visitors are spotted, we'll finally start piecing together what's normal and what's truly extraordinary, drifting between the stars. Whether Oumuamua was a shard of a dead star, the iron heart of an alien exoplanet, or something far more unbelievable, it forced us to admit one thing loud and clear. The universe is still hiding secrets we can barely even imagine. Sure, Oumuamua has long vanished from our telescopes, but the questions it raised and the tools it inspired will drive astronomy for decades. Because this wasn't just about one strange object, it was about a shift in how we search. The quantum AI didn't just peer inside Oumuamua, it rewired the way we hunt for answers in the cosmos. And in doing so, it may have changed forever how humanity looks for evidence of life and technology beyond Earth. So what do you think? Was Oumuamua just a freak of nature? Or could it have been something designed? Let us know your take in the comments, and make sure to hit subscribe, smash that like button, and share this video with anyone who loves uncovering the mysteries of the universe.